In this section, we're going to take a look at how we go about finding limits, both graphically and numerically. So we're going to jump in with an example. We're going to consider this function. This function is f of x equals x squared minus 4 over x plus 2. That function, that rational function, that top part, you could factor it into x plus 2, x minus 2 over x minus 2. And you might be, right here, you might be tempted to cancel out the x minus 2. And in some sense that's okay, except for at 2 itself, at the value 2 itself, this function's not actually defined, right? If we were to plug in 2, we would get a 0 in the denominator. So 0, the x value of 2 is not in the domain of this function. So this function, it's going to behave like x plus 2, right? You can cancel that out. It behaves like that everywhere except for when x is equal to 2. So x is not allowed to be equal to 2 in this function because, again, it would make that denominator equal 0, and the function is undefined. If we were to graph this then, this looks like y equals x plus 2, 1, 2. And if we were to graph that, it has an intercept at a y-intercept of 2, has a slope of 1, except for right at right at 2 itself, we have this hole in the graph. Right? It's not defined when x is equal to 2. And so our graph looks something like this. With this graph, if you were to take a value a little bit smaller than 2, right, then you're going to end up with a value a little bit smaller than 4. If you have a value a little bit larger than 2, you'll end up with a y value a little bit larger than 4. And so when we think about limits, what we're going to think about doing is we're going to ask ourselves, what happens as this point down here gets closer and closer to 2 itself? So when that value of x gets closer and closer to 2, what's happening to this y value? Is it getting closer and closer to a particular value? And from this graph, we can see, oh, there's this hole in the graph. It looks like it's getting really close to the value of 4 itself. Right? That's what it looks like. That's what appears to be happening. Indeed, it is what is happening. So that would be a graphical way, how we could use a graph to determine that limit. Another way we could go about doing that is numerically, and that's what we're going to do here. If we go about finding this numerically, then we are thinking about what happens as we plug in values for x that are really close to 2. So we get values of x that are closer and closer to 2. What happens? So let's start with values of x that are a little bit smaller than 2. So if we take 1.9 and plug it into our function, then we will have an output of 3.9. And then if we were to get a little bit closer, so instead of being 0.1 away, we're 0.01 away, we plug it into our function. You can plug it in here, or you can plug it in here. Either one is going to be okay, and we'll get 3.99. If we have something that is 0.001 below 2, and we plug 1.99 in, we're going to get 3.999. So as we have values that are a little bit to the left of 2, but they're getting closer and closer to 2, it looks like the function value is getting closer and closer to 4. What happens on the other side, right? So let's start way out here at 2.1. So we're 0.1 above 2. We're 0.1 away from 2. If we were to plug that in, we would get 4.1. If we plugged in 2.01, we'll get 4.01. And then we will get 4.001. If we were to look at that as our values are getting closer, as the x values are getting closer to 2 from the right, from values to the right of 2, then it also looks like the function value is heading towards 4. And so what we will say in limit notation, the way that we will write this is we are going to write the limit of f of x as x approaches 2 is equal to 4. In words, we would say the limit as x approaches 2 of f of x is equal to 4. Right. So that is what this means. We are saying the limit as x approaches 2 of f of x is equal to 4. Or the limit of f of x as x approaches 2 is equal to 4. Either way, to say that is going to be okay. So that's the idea of a limit. We are going to go through and we are going to calculate a variety of these. So we'll look at another example in our next video.